Good morning. Welcome to Mission Control Houston, the home of the International Space Station Flight Control Team. This is where there's a group of specialists on duty around the clock to keep an eye on station operations and assist the Expedition 55 crew members on all their science and maintenance tasks. This week, the crew on orbit and the team here in Houston have focused on a launch, a grapple and berthing, and a hatch opening, as a commercial cargo ship has delivered more than 7,000 pounds of supplies to the station.
Houston Station on Space to Ground.
Go Antares! Welcome to Space to Ground. I'm Dan Hewitt. This week started off how all weeks should, with a rocket launch. Orbital ATK's Antares lifted off Monday morning, illuminating the Virginia night sky and delivering the Cygnus spacecraft into orbit. Following the textbook launch and 3-day trip circling the globe, Cygnus arrived at the station on Thursday and was snagged by NASA astronaut Scott Tingle. The vehicle, packed with about 7,400 pounds of cargo, was attached to the Earth-facing side of the Unity module before the crew opened the hatch and got to work. And coming soon to a space station near you, one of the coldest spots in the universe. The Cold Atom Laboratory is a physics experiment that will be producing clouds of ultra-cold atoms called Bose-Einstein condensates, or BECs, where atoms behave more like waves instead of particles. To do all this, atoms will be chilled to about 10 billionths of a degree above absolute zero, which is about 10 billion times colder than the average temperature of deep space. Thanks to the station's microgravity environment, scientists will be able to observe the BECs for up to 10 seconds, way longer than the fractions of a second we see in similar experiments here on Earth. Scientists are hoping to address some fundamental questions in science, like the nature of gravity, dark matter, and dark energy, and could also help improve technologies like atomic clocks used in space navigation, or quantum sensors on spacecraft used for things like monitoring Earth's climate or the makeup of other planets and asteroids. This week's Twitter question comes from Mark Wilson, who wants to know how we weigh astronauts in microgravity. Well, a scale isn't much use, so we had to turn to some fundamental physics. Newton's second law of motion teaches us we can calculate force by multiplying an object's mass by its acceleration. Using the Space Linear Acceleration Mass Measurement Device, or SLAM, we can use two springs to generate a known force against an astronaut and measure the resulting acceleration. With two of the three variables in our equation now known, we can calculate mass. We hope you like what we've done with the place, and keep sending in your questions using the hashtag #SpaceToGround. We'll see you next week.
Off the Earth, for the Earth. Space to Ground.
The cargo on board this Cygnus spacecraft includes supplies for the human crew members, but also materials for many of the hundreds of experiments that'll be running on the International Space Station during Expeditions 55 and 56. Here's a little more detail about some of the science making its debut in space thanks to this commercial cargo vehicle.
Antares on its way.
It's true that quantum mechanics is the science of the very, very small, but due to sort of a twist of fate, it's also the science of the extraordinarily cold. This idea, this sort of relevance, this connection between the very, very cold and the science which underpins the very small, which underpins the future of our economy, is not a new idea. In fact, there are hundreds of groups around the world here on Earth, including mine, which are studying this thing called Bose-Einstein condensation, with this idea in mind. But up in space, we hope to be able to get colder yet. We hope to get to temperatures of about something less than 1 nanokelvin. So we intend to get to within 1 billionth of a degree of absolute zero.
I always ask students, what's the most widely used material on Earth? And the answer is water. What's the second most widely used material on Earth? And that's concrete. For every person sitting in this room, there is 1 ton of concrete being produced and consumed every year. We really need to understand much better what is happening with this material and how we can use it more sustainable on Earth, and how we can make a usage of raw materials present in the space and make a binder, concrete-like, cement-like binder in the space. So if we can make the process pure, because we know from protein research that the crystals will go larger and more ideal in its shape, if we can narrow down the amorphous phases and the crystal phases forming hardened cement paste, maybe we can improve the process on Earth.
So here we are doing essentially a fundamental paradigm shift in the way people have processed chemicals. So we're shifting from a gravity-based paradigm to a surface forces driven. This is the device that we are sending to space. We hope to learn more about how this device works in order to make it better, and so this would benefit Earth applications, hopefully pharmaceutical production. In terms of exploration of deep space, you need to have the capability of making molecules. So you need chemical processing capabilities, and this, if it works in the way we hope, would enable certain steps in order to pave the way towards chemical synthesis in space. And of course, there's a very exciting horizon.
All three of us up here have projects that are based on the use of small satellites called CubeSats. All three of these projects are Earth-observing missions. From the ISS, we later in the summer get pushed out into orbit, into free-flying orbit. We've built a new processor that's a very capable processor. It'll be the first time a processor like this has been used in space.
We still don't know exactly when the cloud forms and when it rains. And we need to observe these storms as a function of time at one space. So this whole project is about developing all the technology that what we used to do from huge systems into shoebox size.
Right now it's a technology demonstration that is, if successful, soon we'll see constellations of these small radars together with radiometers, which will significantly improve weather and climate forecasting and our understanding of the water cycle.
The exterior of the International Space Station is a good spot for science, and commercial businesses and scientific researchers are using that real estate to capture digital imagery of Earth. MUSES, the Multiple User System for Earth Sensing facility, is a platform on the outside of the station that can hold 4 different payloads, ranging from high-resolution digital cameras to hyperspectral imagers, which will support several varieties of Earth science observations.
There's 4 places for 4 individual payloads to be mounted. These 4 places provide an individual scientist or a commercial endeavor to use this platform for acquiring access to space-borne opportunities for looking at the Earth. MUSES is a multi-user system for Earth sensing. It's the first of its kind that actually allows the change-out of payloads on board this particular system. Robotic interaction with the onboard space station remote manipulator system actually allows plucking a payload off of this and replacing it with a new one. This is our server drawer. It's designed to take the volumes of data that we collect on board the MUSES externally and house that for temporary storage on board the U.S. laboratory for subsequent downlink to the ground. We actually have shoved 18 terabytes of data storage capacity in this single drawer that goes into the express rack. So one of its kind and first on board.
One area of research being conducted on board the International Space Station is science that teaches us how to make long-duration missions in space safe and successful journeys for the human explorers. And that comes from learning how the human body reacts during prolonged exposure to the space environment. We're also looking into how we can provide the supplies that explorers will need on missions to deep space that will last for years. Supplies such as fresh food.
Space gardening. Presented by Science at NASA. Roman statesman Marcus Tullius Cicero said, "If you have a garden and a library, you have everything you need." Humans attempting someday to make Mars their home may well share the sentiments expressed by the orator from ancient Rome. As for the library, books can now be stored digitally. But how does your garden grow in space? To find out, scientists have been studying plant growth on the International Space Station, or ISS. The results could help boost the productivity of both extraterrestrial and earthly gardens. Recently, the ISS has been home to some impressive harvests, yielding tasty snacks for crew members. However, scientists aren't through trying to unlock the secrets of how plants grow away from home. Future space outpost dwellers will need to grow plants for food and for recycling air and water, says Annalisa Paul of the University of Florida. So we're studying how plants adapt to the spaceflight environment. Our findings will also help us understand how plants might respond to new and challenging environments here on Earth. Paul and her colleague Robert Furl have been growing plants in space since 1999, when they launched their first experiment on Space Shuttle Columbia. Several space station experiments followed. One of their most compelling discoveries was that certain root growth strategies assumed to require gravity really don't. Plant roots seek water and nutrients by growing away from where they're planted. To determine which direction to grow, terrestrial plants use gravity as a cue, and they use touch to maneuver around obstacles. In the late 1800s, Charles Darwin demonstrated that plants growing along a tilted surface don't send their roots directly away from the seed, but instead send them to the right or left. He hypothesized that this growing pattern, called skewing, was caused by a combination of the roots touching their way across the slanted surface and gravity pulling straight down on them. In an experiment in 2010, Paul and Furl discovered, however, that roots of plants growing in microgravity on the station skewed like their earthly counterparts. The ISS showed us something we never would have known otherwise, notes Paul. Gravity isn't essential in root orientation. Good news. That's one less impediment to growing plants in space. Plants will efficiently seek the nutrients they need without gravity as a cue. The experiment also studied the patterns of genetic expression. Space plants changed the way they expressed their genes in order to produce specific proteins helpful in zero gravity. Paul explains, when living organisms are faced with environmental change, their response almost always involves a change in genetic expression. To cope, they switch on and off certain genes. Plants are pros at this. Paul says, plants' cell walls undergo a kind of remodeling in space. The genes associated with a cell wall are often in the opposite switch positions than they're in on Earth. The researchers aren't yet sure what purpose this serves, but they intend to find out with additional experiments. Paul and Furl aren't alone. Many other scientists have also been studying plant growth on the space station to unlock the secrets of successfully growing plants in this novel environment. At the heart of all the research is the quest to provide humans with everything they need, wherever they may be. For more about gardening in space, visit www.nasa.gov/station. For more on the growth of science both on and off our home planet, visit science.nasa.gov.
On the subject of astronaut health in space, consider this. If you live in an environment where your muscles don't even have to work against the pull of gravity, you need some help with exercise. On the International Space Station, the crew members have a whole suite of exercise equipment at their disposal, including a treadmill. In this Speedy Time segment, astronaut Jack Fisher runs through the workout they get on the Combined Operational Load-Bearing External Resistance Treadmill in the Tranquility Module.
Hello, and welcome back to Speedy Time. Today we're going to figure out how you get some aerobic exercise on the space station. One way is by running. We have a special treadmill. First off, we got to find it. Where is it? It's on the wall. How cool. We first get a heart rate monitor. Next, we get our super duper harness. Next off, we connect in to the T2 itself. These are very important because they simulate load that we would have on Earth, and they pull us to the treadmill. Otherwise, we'd just float off. We make sure that it's calibrated, and we start. A light jog.
A little higher pace.
We even have a mode called passive. You push it yourself. And then the coolest part of the whole thing is at the end of your workout, it gives you the miles traveled, not just the miles ran. So, using the speed of the space station, 17,500 miles an hour, you can go like, I don't know, 9,000 miles. That's a pretty good run.
Now, not all the science on the International Space Station is about human beings. Some of it is designed to learn about the space environment for its own sake. For example, we know neutron stars are small and extremely dense, but there are still many aspects of these remnants of the explosive deaths of other stars that we don't understand. NICER is a facility on the outside of the station that seeks answers to decades-old questions about extreme forms of matter and energy. And data from NICER will also be used in Sextant, an onboard demonstration of pulsar-based navigation. Another aspect of the mission of the International Space Station is to connect students and teachers to the important research that's conducted on orbit. It's done through hands-on activities, videos, and up-to-the-minute education news. The Year of Education on station is designed to help teachers enhance their K-12 curricula in the STEM fields of science, technology, engineering, and mathematics. And that includes opportunities for students to talk to astronauts aboard the space station.
Everything we're doing is trying to inspire the next generation of spaceflight explorers. I think they're starting to realize that they're the generation that's going to make the next giant leap, that we're going to go to Mars and they're going to get to be a part of it. What we're looking to do is really bring subject matter experts into the classroom for the students and educators. So again, it's so important to hear from the experts firsthand and get almost like that mentorship from them. STEM on Station is kind of a collective of all the resources and opportunities available for students and educators related to the International Space Station. We do some things called in-flight education downlinks, where students on the ground get to talk to astronauts living and working on board the International Space Station. 20-minute question and answer conversation. And so they're learning firsthand from the astronauts what it's like to live and work in space. We do some STEM-based design challenges. So we wrapped up something very recently called Mission Imagination. There it challenges students to take a look at how the International Space Station is helping us get to Mars. So looking at systems on the space station, how they currently work, and how we're going to have to change them just a little bit to help us get to Mars. And we have another program that's going to take a look at the expeditionary skills that the astronauts need. And these are skills like communication, teamwork, self-care, that really helps them be successful in their STEM careers. We're working off the Earth, for the Earth, and in the classroom.
There's science about space, and then there's science to support future space exploration. And some of the science done on the International Space Station is aimed closer to home, to helping improve the lives of we Earthlings who never get to leave the planet. Take a look at just a few examples.
The International Space Station is the most fantastic vehicle ever built.
It's a one-of-a-kind laboratory orbiting about 250 miles above the Earth.
And we perform experiments on the International Space Station.
We can do science, we can do experiments, we can learn how to do things out of this world. And the result will help benefit the people on the ground.
Space Station really provides an opportunity to explore, for example, say medical applications.
The aging and the osteoporosis and muscle wasting conditions are greatly accelerated in microgravity.
The weightless environment will give us insights into things like diabetes and maybe even cancer.
Understanding those phenomena allow us to look at how we can improve treatment of disease here on Earth.
If we wouldn't have conducted experiments on the ISS, we wouldn't have known that you could use cold atmospheric plasma in such broad application areas we're now exploring.
One of the most promising results has been gained by studying a protein associated with Duchenne muscular dystrophy.
We may be able to slow the disease by half, potentially doubling the lifespan of many of these DMD patients.
We provided eyes-serve imagery for many natural disasters, including floods and fires, for deforestations, for volcanic eruptions, and for earthquakes. So it was really a fantastic example showing how imagery from the International Space Station could be used in these times of dire need.
This was when we realized we had a chance to make a difference in the world using the same technology that was used by NASA, but applied in a remote area of a developing country.
I think it's made people much more aware of the issues of water quality. That's a very powerful thing.
Having the HYCO on the International Space Station has been the ideal test bed for our research.
We can monitor these water bodies from space, and if we can reduce exposures both to humans and even animals, then we've achieved our goal.
And now today, we're able to operate the largest fleet of Earth imaging satellites in human history.
And none of that would have been possible without the International Space Station.
The space station has done so many things for life on planet Earth. It shows us what human beings can do working together. It shows the science that we can discover.
Over 2,000 experiments have flown on board ISS. 170 countries around the world have participated in some fashion, either in the ISS itself or in one of the experiments. Our rate of research is actually increasing. We're doing more today on board the space station for research than we have ever done before, and that's only going to continue in the future.
And so what we're seeing today is a proliferation of new ideas and new concepts. It's almost like it's a renaissance of what's happening in space. Buckle up and strap down, because this is going to be a rocket for all of us in the global community to be part of.
Flight engineer Scott Tingle has about 10 days left on his first space flight. He and Soyuz crewmates Anton Shkaplerov and Norishige Kanai are due back on Earth on June 3rd, and will probably come home with new stories of inspiration gleaned from seeing the entire world from a whole new perspective. Before he left Houston last year, Tingle spoke about the career that had led him to the point of leaving the planet and the inspiration he gained on each step of that journey.
I've had the opportunity to do a lot of great things in a 30-year career, engineering, flying airplanes, and now here with NASA. And the groups of people that I've worked with have been absolutely incredible. Well, the one consistency across the board is that they have provided me with a lifetime of inspiration. So I grew up in the town of Randolph, Massachusetts, kind of a small town, and the folks at home knew how driven I was. They knew how interested in science, engineering, and space flight I was, and they were nothing but supportive the whole way. There's literally thousands of people that I've worked with in my military career. Absolutely unbelievable. Some of the most inspirational young Americans you'd ever meet in your life. You'll walk down in the bowels of the ship and you'll see these 18, 19, 20-year-olds covered head to toe in grease, just coming off a 24-hour shift so that we could fly our airplanes safely and efficiently. Absolutely inspirational. When things get hard for me or challenging, I think of those folks, and it makes me want to do better. And that's one of the things that I'm finding is very consistent throughout my career. When I came here, we've got civil servants, we've got contractors, we've got military, you name it. And we all have one goal, one mission, and watching the team work together is just inspiring. My ultimate inspiration is the love and support I get from my family. They've been so solid over the years that there's absolutely no way I could be doing all this without their support. I'm Scott Tingle, and I'm a NASA astronaut.
If you'd like to get another look at any of the stories we featured today, and who wouldn't, check us out on YouTube and Facebook. There are the addresses right there on the screen. And while you're at those spots, take a look around at all the other great stuff you'll find about NASA and America's human spaceflight program. Now, if you're interested in good conversation about space exploration, check out Houston, We Have a Podcast. That features folks from here at NASA talking about their work and their experiences on the job. New episodes post on Fridays, and today, May 25th, in recognition of Asian Pacific American Heritage Month, my colleague Gary Jordan talks with members of the Asia Employee Resource Group at the Johnson Space Center to hear the stories of how they got to NASA and about the work they do here. Go to www.nasa.gov/Johnson/HWHAP. Houston, We Have a Podcast. You'll find all of our episodes there. You can also listen to them all on iTunes, Google Play, and SoundCloud. This is Mission Control, Houston.